Welcome back to the Microsoft DP-600 Practice Question Series, Implementing Analytic Solutions Using Microsoft Fabric. This is Episode 4, the first of 3 episodes covering DAX and semantic model questions from the exam bank. Today, 13 questions on DAX functions, measures, and report behavior. Let's begin. Question 1 of 13. You have a Fabric tenant that contains a Power BI report named Report 1. Report 1 includes a Python visual. Data displayed by the visual is grouped automatically, and duplicate rows are not displayed. You need all rows to appear in the visual. What should you do? A. Reference the columns in the Python code by index. B. Modify the sort column by property for all columns. C. Add a unique field to each row. D. Modify the summarize by property for all columns. You have 10 seconds. The correct answer is C. Add a unique field to each row. Microsoft's own documentation on Python visuals states it directly. You can add an index field to your dataset that causes all rows to be considered unique and prevents grouping. That's option C. Why the others fail? A. Referencing columns by index inside the Python script happens after Power BI has already grouped the data, so it's too late. The duplicates were already collapsed before the script ran. B. Sort column. By only controls display order, not which rows get merged. D. Summarize by controls how numbers are aggregated, sum, average, etc. It does not stop row-level grouping, so identical rows still collapse into one even set to don't summarize. Question 2 of 13. You have a Fabric tenant that contains a semantic model with data about retail stores. You need to write a DAX query, executed via the XMLA endpoint, that returns a table of stores opened since December 1st, 2023. Complete the DAX expression. Complete the expression using words from the word bank. Define, evaluate, summarize, table, filter. You have 10 seconds. The correct order is define, then evaluate, then summarize. Per Microsoft's DAX queries. Documentation, define introduces variable/measure definitions and must precede the first evaluate. Evaluate is the one required keyword that introduces the table expression to run. And summarize is a valid table function that groups store by name and open date, so filter has something to test. Table and filter, the other word bank options, don't fit these specific blanks. Table isn't a DAX query keyword at all, and filter is already used later in the expression. It can't also be the function that produces the grouped rows filter operates on. Question 3 of 13. You have a Power BI semantic model. You plan to implement calculation groups. You need to create a calculation item that changes the context from the selected date to month to date, MTD. Complete the DAX expression. Complete the expression using words from the word bank. Calculate, generate, measure, combine values, selected measure, selected value. You have 10 seconds. The correct order is calculate, then selected measure. Microsoft's official calculation groups documentation gives this exact pattern, MTD equals calculate. Selected measure, dates MTD date. Selected measure is a placeholder for whatever measure the calculation item is applied to. And calculate is what lets you layer the date's MTD time filter on top of it. The other word bank options don't fit. Generate and combine values are table functions with unrelated purposes. Measure is a define block keyword rather than something you nest inside a calculation item, and selected value returns a single value from a column. It has nothing to do with referencing the in-context measure. Question 4 of 13. You have a Power BI semantic model with measures that use multiple calculate functions and a filter function. You are evaluating measure performance. In which use case will replacing filter with KEEPFILTERS reduce execution time? A. When the filter function uses a nested calculate function. B. When the filter function references a measure. C. When the filter function references columns from multiple tables. D. When the filter function references a column from a single table that uses import mode. You have 10 seconds. The correct answer is D. When the filter function references a column from a single table that uses import mode. Microsoft's own guidance, Avoid using filter as a filter argument in DAX, explains why. Import mode tables are in-memory column stores specifically optimized to filter columns via Boolean expressions. KEEPFILTERS lets you write a Boolean filter instead of a filter, values, table expression, so the engine can push the filter straight to that optimized path. That's option D. Why the others don't fit. A. A filter nested inside another calculate is a row context/context transition scenario, not the single column case this optimization targets. B. Referencing a measure inside filter forces row-by-row evaluation regardless of KEEPFILTERS. The measure still has to be evaluated for every row. C. Filtering columns from multiple tables needs a different, more complex KEEPFILTERS pattern. The documented single-column import mode speedup specifically doesn't apply the same way. Question 5 of 13. You have a Power BI semantic model with a measure named total sales amount, which returns a sales revenue amount translated into a selected currency. You need total sales amount to be formatted with the correct currency symbol. What should you include in the solution? A. A field parameter. B. A linguistic schema. C. A dynamic format string. D. The window DAX function. You have 10 seconds. The correct answer is C. A dynamic format string. A dynamic format string lets a measure's display format change per evaluation, based on the current filter context, exactly what's needed when the currency symbol depends on which currency is selected. Why not the others? A. A field parameter switches which field is displayed, but it's documented that field parameters don't carry per selection format string logic. They can't make one measure render with different currency symbols. B. A linguistic schema is for natural language Q and A, unrelated to number formatting. D. Window is a DAX function for windowed row calculations, like moving averages. It has nothing to do with formatting. Question 6 of 13. You are creating a report and semantic model in Power BI Desktop. The value measure uses a switch expression based on the selected metric. If the metric is number of customers, it returns a whole number format. If it's gross margin %, it returns a percentage format. Otherwise, it returns a whole number format with a 1000 separator. The format field shows dynamic. First, which feature was added to the value measure? Choose from calculation group, data category, dynamic format string, synonym. Second, what value formats can the value measure return? Choose from percentages only, percentages or decimals, whole numbers only, percentages or whole numbers. You have 10 seconds. The correct answers are: first, which feature was added to the value measure? The answer is dynamic format string. Second, what value formats can the value measure return? The answer is percentages or whole numbers. The switch expression is plugged directly into the format field showing dynamic. That's a dynamic format string, not a calculation group, which changes calculation logic, not formatting. A data category, which classifies a field for maps/Q and A, or a synonym, AQ and A alias. For the second blank, the three switch branches resolve to hash or ###0, whole number formats, or 0.00%. Percentage format, never a decimal format. So percentages or decimals, and percentages only, and whole numbers only are all incomplete or wrong. Only percentages or whole numbers covers every branch the switch can actually produce. Question 7 of 13. You have a semantic model named Model 1 relating customers and bank account balances. DIM account, account key, surrogate key, account number, business key, fact transaction, date, account key, FK to DIM account, amount, DIM customer, customer key, surrogate key, customer ID, business key, customer name. A customer can have one or more accounts. Each account can be associated with multiple customers. You need users to query Model 1 for total transaction amounts by customer. What should you add to Model 1? A many-to-many relationship between fact transaction and DIM customer. B. A bridge table with relationships to DIM customer and DIM account C. A bridge table with relationships to fact transaction and DIM customer D. The customer key column in fact transaction and a relationship to DIM customer. You have 10 seconds. The correct answer is B, a bridge table with relationships to DIM customer and DIM account. This is documented directly in Microsoft's many-to-many relationship guidance under Relate Many-to-Many Dimensions. Customers and accounts are many-to-many, so a bridge table connecting DIM customer and DIM account resolves it, letting fact transaction to DIM account to bridge to DIM customer aggregate correctly. Why the others fail: A direct many-to-many relationship between fact transaction and DIM customer skips DIM account entirely, which doesn't match the actual key structure. C. A bridge table linking fact transaction and DIM customer bypasses DIM account too. The bridge needs to sit between the two-dimension tables, not between the fact and one dimension. D. Adding a customer key column to fact transaction assumes one customer per transaction, which contradicts the stated many-to-many customer account relationship. Question 8 of 13. You have a Power BI semantic model with a single table, orders, product name, order date, quantity. A report page named Inventory has a slicer for product name and a clustered column chart showing quantity by order date. You need users to switch the chart between quantity by product name and quantity by order date. The solution must minimize development effort. What should you create? A measure. B. A dynamic format string. C. A field parameter. D. A calculation group. You have 10 seconds. The correct answer is C, a field parameter. Microsoft's field parameters documentation describes exactly this. Readers dynamically change the dimension a visual is analyzing by picking from a slicer, with no extra DAX or modeling required. Why not the others? A measure alone can't swap which column the chart's category axis uses. B. A dynamic format string changes how a value is displayed, not which field is plotted. D. A calculation group changes how a measure is calculated, e.g., time intelligence, not which dimension is used for grouping. Wrong tool for an axis switching requirement. Question 9 of 13. You have a semantic model with a sales table containing sale date, store ID, and product ID, a product table, a store table, and a campaign table containing campaign date, campaign ID, product ID, store ID, name, and description. Products and stores can each be part of multiple campaigns, and multiple active campaigns can exist at once. You plan a report showing sales made after a campaign for a given store. You need to add a table to the model and configure cardinality for its relationships. Type of table. Choose from bridging, dimension, fact. Cardinality. Choose from many to many, one to many, one to one. You have 10 seconds. The correct answers are type of table. The answer is bridging. Cardinality. The answer is many to many. Products and stores can each belong to multiple overlapping campaigns, so campaign can't attach to sales through a simple one-to-many relationship without ambiguity. A bridging table is the standard Power BI pattern for this. One caveat worth flagging. Microsoft's own bridge table walkthroughs typically configure each individual bridge-to-dimension link as one-to-many. The bridge table sits on the many side of two separate links, even though the overall design is described as resolving a many-to-many relationship. Without the original answer image, we're going with many-to-many as the most literal reading of this question's cardinality dropdown. But if you're studying this exact pattern, it's worth checking both conventions. Question 10 of 13. You have a semantic model with sales, product, and location tables. You're creating Measure 1 to calculate the percentage of all sales for a selected product. The formula divides total sales amount by the total sales amount recalculated with all filters removed from the product table. In other words, the current product's sales divided by the grand total across all products. For each statement, is it yes or no? Statement. Measure 1 will return an error if there are no sales for all products. Statement. Measure 1 will return a decimal value that represents the ratio of the current product's total sales to the total sales across all products. Statement. The denominator of Measure 1 will be calculated by using the modified filter context created by the REMOVEFILTERS. Product DAX function. You have 10 seconds. Measure 1 will return an error if there are no sales for all products. No. Microsoft's divide documentation is explicit. If an alternate result is not passed in, and the denominator is 0 or blank, the function returns blank. No alternate result was supplied here, so a 0 denominator returns blank, not an error. That's the entire reason divide exists instead of the plain slash operator, which does raise a divide by 0 error. Measure 1 will return a decimal value that represents the ratio of the current product's total sales to the total sales across all products. Yes. That's exactly what the formula computes. The numerator is sales filtered to the selected product. The denominator is sales with the product filter removed, the grand total. So the result is the product's share of all sales. The denominator of Measure 1 will be calculated by using the modified filter context created by the REMOVEFILTERS. Product DAX function. Yes. REMOVEFILTERS. Product inside the calculate for the denominator strips any filter on the product table, which is precisely what turns total sales amount into the unfiltered grand total for that denominator. Question 11 of 13. You have a Power BI semantic model with a date table containing fiscal month, January to December, and month number, 1 to 12 columns. You need visuals using the date table to appear in chronological order. Minimizing administrative effort. What should you do? A. Sort the month number column by column. B. Sort the visuals by using the Sort Ascending option on fiscal month. C. Sort the fiscal month column by column. D. Sort the date table by column. You have 10 seconds. The correct answer is C. Sort the fiscal month column by column. Sort by column tells Power BI to always sort fiscal month using the order of month number everywhere it's used, in any visual, automatically, with a one-time setup. Why not the others? A. Sorting month number by column would need a column to sort BY. But month number is already the numeric key. There's nothing to attach it to. And it doesn't fix fiscal month's display order anyway. B. Manually sorting each visual has to be repeated on every single visual that uses fiscal month, which fails the minimize administrative effort requirement. D. There's no sort the table operation in Power BI. Sorting applies to columns and visuals, not whole tables. Question 12 of 13. You have a semantic model, Model 1, with fact table fact sales related to dimension table dim date on order date. You add a second relationship between fact sales and dim date based on shipped date. You need to filter by ship date in a new report without affecting existing reports. Which two actions should you perform? Select 2. A. Enable the ship date relationship. B. Use a related table DAX function. C. Use a cross-filter DAX function. D. Use a user relationship DAX function. E. Disable the ship date relationship between the tables. You have 10 seconds. The correct answers are D and E. Use a user relationship DAX function. Disable the shipped date relationship between the tables. A table can only have one active relationship between the same two tables at a time, so the new shipped date relationship must stay disabled, inactive, to avoid breaking existing reports built on the active order date relationship. User relationship then activates shipped date on demand, inside just the specific measure that needs it. Why not the others? A. Enabling shipped date would make it active, which automatically disables order date instead, breaking every existing report that relies on it. B. Related table returns a related table for row context calculations. It doesn't switch which relationship is used for filtering. C. Cross-filter changes filter direction, single versus both, not which of two relationships is active. Different problem entirely. Question 13 of 13. You are designing Model 1 for a financial analytics workspace. Measure 1 returns total sales. A currency table's format column holds per record currency formatting strings, $hash, hash hash, 0.00, / euro sign hash, hash hash 0.00, / yen sign hash, hash hash 0.00. You create. Format equals selected value. Currency format. You need measure 1 to display with 2 decimals and the correct currency symbol. Minimizing logic duplication. What should you do? A. Create a dynamic format string for measure 1 that references the format measure. B. For Model 1, set the data category of measure 1 to country/region. C. For Model 1, set the format type of measure 1 to currency. D. Copy the DAX expression from the format column and paste the expression into the format string expression of measure 1. You have 10 seconds. The correct answer is A. Create a dynamic format string for measure 1 that references the format measure. Pointing measure 1's dynamic format string at the existing format measure reuses that logic directly from one source of truth. Change the format column's logic once, and measure 1 stays correct automatically. Why not the others? B. Data category, like country/region, controls how Power BI classifies a field for maps and Q&A, not how numbers are formatted. C. Format type. Currency applies one fixed currency symbol to every value. It can't switch symbols per selected currency. D. Copying the DAX expression into measure 1's format string does work, but it duplicates the formatting logic in two places. Any future change to the currency table's format strings would need to be updated twice, which directly violates minimize logic duplication. And that's all 13 questions on DAX functions, measures, and report behavior. The full answer key is on screen. Question 1, C. Question 2, define then. Evaluate, then summarize. Question 3, calculate, then selected measure. Question 4, D. Question 5, C. Question 6, dynamic format string in percentages or whole numbers. Question 7, B. Question 8, C. Question 9, bridging and many-to-many. Question 10, no, yes, yes. Question 11, C. Question 12, D and E. Question 13, A, Teixa. Drop your score in the comments. How many did you get right out of 13? In Episode 5, we continue with DAX performance and query optimization. Coming soon. Subscribe so you don't miss it. If this helped, please give it a like and share it with anyone preparing for DP-600. See you in Episode 5.